Welcome. Today we are going to find a value for pi uh, using Excel. Pi, which is required to find the circumference of the circle. When we know for the to find the circumference of the circle, we should know the value for pi. So today we are going to approach to a value for pi. So to do this, you have to have a Excel software only. So let's move to the idea. Here is a circle, blue color circle. Here I mentioned by R, which is radius. Here this is D, represent by diameter, and C is for circumference. You know circumference mean the length of the outline. If we draw a line around this circle, the length of that line is circumference. D means diameter, which is here is the midpoint of the circle, and from here to here the line going through the midpoint. Here from here to here length is diameter, and from midpoint to here to the end, this length is radius. Radius is half of the length of the diameter. So if we need to find the circumference of a circle, this is the formula, 2 pi r. So we know the value for pi. Sometimes we have take 22 by 7 or 3.143, like that, 2 pi, and r is whatever. For any given circle, if we have the value for r, then we can find the circumference of the circle. So in this video we are going to focus on not to find the circumference, but to find value for pi. How we get the value 3.143 or 22 by 7 for pi. Before start, we should know for any circle, for every circle, for any circle or for every circle, the ratio C divided by D. C means circumference, D diameter. If we divide the circumference by diameter, which is a constant value, which is not changed for circle to circle, it is fixed value. So for that value we have we have identified as pi. So this pi is not changing, it's a constant value. but it's not a integer value, it's a decimal value, but it's not changing. If we draw a small 1 centimeter radius circle here, then the ratio between C and D for that 1 centimeter radius, it's not change. And if we draw a 1 meter large circle, for that circle, if we take the ratio C divided by D, it will also become the value same as for previous. We had taken the value, we took value. Likewise, the pi is not change for any circle. So that is the one idea we are going to apply here. So the next idea is to find a value for pi. We are not going to find the real, that mean real circle, find a value for real circle, but we are going to find a very large number of regular polygons perimeter. That mean we are going to assume the very high number of side regular polygons perimeter is approximately going to equal to the circle's circumference. So that is another idea. For this calculation, we are going to use Excel. So let's see how to find the value for pi. Here I am going to show you a thing that how a polygon, regular polygon, will be a circle. Here I take 6-side regular polygon. Here this is a 6-side regular polygon, and all sides of this polygon is equal. That means the AB, length of AB, BC, see, all sides are equal, then only we call that is a regular polygon. So this is a 6-side polygon. Likewise, we are going to double the sides of polygons. Here 6-side, we are going to double it. That means 6-side going to 12. Six sides going to 12. So here you can see this is a 6-side polygon, then this is a 12-side polygon. Then we are going to draw a 24, we are going to double it, 24 sides regular polygon. This is a one side length, and we are going to give the sides 24. Here you can see the difference between the first polygon and third polygon. It slowly approach to a circle. but it only have 24 sides. But in this video we are going to using Excel, we are going to we are going to take a polygon which sides are 24,000, like so. This is only 24 sides. We are going to take 24,000 sides, so it surely going to be a approximate value for approximate value for circle. So let's double it this 24 side into 48 side regular polygon. So this is one side length, and we are going to double the 24 into 48. So this is a very smooth circle when we compare to this 6-side polygon. So what the thing we are going to do here is we are going to find the circumference of the polygon. We can find the circumference of the polygon, and from circumference of the polygon we are going to find circumference of the circle, and then we are going to find the value for pi. Okay, let's move to the other section. Here you can see the very first regular polygon which has 6 sides, 1 side, 2, 3, 4, 5, 6. This is 6-side regular polygon, and here we have to note some things. Here each and every sides are equal, and the radius of this polygon and radius of the circle are equal and taken as 1 unit. Here 1 unit, which means this is midpoint of the circle and midpoint of the polygon as well. So from here to here it is 1 unit, radius is 1 unit. So this is, if this is 1, then this is also 1, because the radius are equal. So this is also 1, 1, 1, and this polygon's this length is also 1, because this is a regular triangle. This is 1, this is 1, and this is 1. So earlier I said that the pi is the ratio of between circumference of the circle and diameter. So here the diameter is here 1 and here 1. 1 plus 1 is 2, but the circumference we don't know. We have to find the circumference. To find the circumference of this circle, we are going to find the perimeter of the polygon. Then by finding the perimeter, we are going to approach and we are going to assume that perimeter is the circle of the circle. So we have some geometrical works here. This is a equal triangle or regular triangle which sides are equal and sides are 1 unit. This whole length is 1. Now we are going to draw a perpendicular line from midpoint here to up to here, which meets circle's arc. Here from we denote here A. The A is the length from here to here, this point to this point, that length is A, and B denoted the length from this point to this small length. The S1 is represented by this whole length side of the polygon, and S1 by 2, which is this point to this point. You know, if we draw a perpendicular line from one vertex to other side, then that perpendicular line divides equally the other side. So this side and this side length are equal, and this also perpendicular. This is perpendicular and these two sides are equal. So here's some formula to find A. We know Pythagoras theorem. We can apply in a perpendicular triangle. In a triangle, for one angle is 90 degree, then we can take Pythagoras theorem for finding the sides. So this triangle is a perpendicular triangle, not a perpendicular triangle, which has a word this angle is 90. So we can use Pythagoras theorem. We know this side is 1, this side is S1 by 2. We know this S1 by 2, and we can find the A. You know, Pythagoras theorem tells us the sides of square size is equal to A square plus B square equal to C square. In Tamil we call this is Shempakam. Shempakathin varkam equal மற்றைய இரண்டு பக்கங்களோட வர்க்கங்களின் கூட்டுத்தொகை. So here A is A வந்து செம்பக்கம் அல்ல, ஒன்று செம்பக்கம், அவை ஒன்றின் வர்க்கம். அதே போல் இது s1/2 a வர்க்கம் plus s1/2 all things square is equal to 1 square. So we can find a. Likewise we can find b. B is here to here, this length. We know from here to here it is 1, the radius is 1. We found the a here to here, this length a. So if we subtract the whole length from this a, then we can get b. So we found value for b, and we are going to find s2. The s2 here is the s2 is the new polygon's one side's length. You know this, you can see this one side, 6 sides polygon becomes double, 2 sides here, 1 2. So the new side of the polygon is s2. You can see if we draw here 1 2 1 2, so 2 4 6 8 10 12. So this 6 side polygon will become 12 side polygon. So we can find new length of the new polygon s2. How we can find this? The s2 is here also, this is a this value b we know, this value, this length s1/2, and the new polygon's one side is செம்பக்கம் s2. So this is we can use here Pythagoras theorem to find the s2. Here once here this one is b, this is s1/2, then we can find s2. If we take square root of this side's square, b square, plus this side square, s1/2 all things square, this whole thing square, and square root of that value will s2. So let's move to the other section. Here you can see we have found here the value for pi is 3.141. How? We have used the Excel and some formulas here, and here the theorem we talked previous, that theorem, geometrical theorem, and here we use some formula in Excel, and finally we have found the value for pi. Here this is the number of sides of that polygon, that doubling. So 6-side polygon becomes 12 side, 24, 48 becomes 92, and likewise here you can see this is 24,576 side polygon, regular polygon. Hence its value also already approached to the pi value 3.141 here. So but we didn't stop here, we moved to this is 2,516,000,000 no 25,165,824 sides, regular polygon. It's surely a very smooth circle, and its pi value is 3.114. So let's move to the real section of this video. So we are going to look at the Excel sheet. Here this one is number of sides of the regular polygon, and this is S. S means the length of the one side of the regular polygon. This is S by 2. That length we have to divide it by 2. This length S1 by 2, that is S by 2. A, you know A, I already told that A is this length. B, you know B is this small length. The new S is the new polygons, the new double sides polygons, one side length, which is new S. And P is perimeter of that polygon, and this is the value for pi. Pi is the constant value for each and every any circle. The ratio between the circumference and diameter is constant, that is pi. That value pi is here. So let's do one by one. Here we have to take 6-side polygon. So here we take 6-side polygon, and we know S is, we have taken here is the radius, and one side length is 1 unit. Any measurement, 1 centimeter or 1 meter or even 1 kilometer. So we take 1 unit, and we need here S by 2 to find A. To find A, we need S1 by 2, this S by 2 length. So S by 2, we can write the formula, this S divided by 2. So Now we can find a, this a. How the a is, we can use Pythagoras theorem to this triangle to find a. So a is equal square root, I write the formula of mentioned here, square root the Sempakam, the 90 degree angle side is 1 unit minus the one side of the polygons divided by 2 and have to square it. So 1 minus, we are going to square this s by 2, square, and bracket closed. So when we press the enter, there is a number 0.8. The value for this a is 0.866. Now the next part is we have to find the value for b. So let's find the b. B is how to find b? The whole length is radius, which is 1 unit. When we subtract a from that 1 unit, then we can get this small space value b. So here this is another formula. We have to subtract a from 1. This is a. So when we press enter, there is a value for this small space b, which is 0.13397. So we found a, we found b. Then we have to find the new polygons one side value. So let's find new s. To find out new s, I have already explained that this is also a triangle which can apply Pythagoras theorem, and this new s, the side of the new polygon, is the opposite side of the 90 degree angle. So we can use Pythagoras theorem and find the value for s, new s. So let's enter the formula. New s is equal square root b square. Here this is b, so we have to shift and press the 6th number, so that is square, and square is number 2 plus, we have to add the s1 by 2 whole thing square. This is s1 by 2, this is s1 by 2, and we have to square it. Shift and press the number 6, you will see this square sign, and we have to enter the 2. So let's close the brackets. Then the new polygon's one side length becomes half, 0.51. Here you can see this, if this length is 1, then the new s should be lower than the 6-side polygon, so it becomes new s. So if we assume this 6-side polygon is the circle, the 6-side polygon is the circle, then we can find the pi from that. How? First we have to take the circumference. Circumference means for curved lines. Perimeter is for that square shape or polygons. So we have to find the circumference of that polygon, perimeter. So one side is 1 unit, the perimeter will be 6 here. The perimeter is equal how many sides in that polygon, and we have to multiply it by the length of one side. Here we took one side of that polygon's length is 1 unit, so it is 6. Then we can find the ratio P upon D, diameter. So here the diameter will not change for any number of sides of the polygon. This diameter is remains same. So P over D is, ratio is, P is here 6 divided by the D, the diameter will not change, 2 units. So the pi is, this is equal this ratio, the constant value. So if we take a 6-side polygon as a circle, and the value for pi is 3. So likewise we are going to increase the number of sides of the polygon. Here we are going to add another formula, which is this one multiplied by 2. Then the new polygon is 12 sides, and the S is the new S. The previously we took the new S, so this one should be equal to this one, and we know this S by 2. The S by 2 is this one divided by 2. This is equal this value divided by 2, and the A and the A is same as we can find geometrically then and using Pythagoras theorem. So I use the same formula used here. So the A will be 0.9 and the B will also the same formula for previous we use, and the new S, so we are going to find the new S for here 12 side, and the double will be 24 side polygon. The new S for 24 side polygon is 0.26. you can see here the value is decreasing. Value should be decreased, and this P is perimeter of the new polygon 6 side 12 side polygon. The 12 side polygon, the one side of the length is 0.5 and there are 12 sides. So if we multiply this 12 into 0.517, then we can find the perimeter. Same formula, and we can also find the ratio using the same formula 3.1, and we can find the value for pi. So we are going to here double the sides of the polygon 24. The new S for here this 24 polygon is here, this 0.26 it should come, the 0.26105 0.26105, this value comes here, is divided by 2, 0.99. Same formula we can use. So you can see the value for pi is approaching smoothly. When we increasing the number of sides of the polygon, it will it will approach to circle, and the value of pi is also approaching its real value. So likewise we can take 192 sides polygon. So we take here so in 192 sides polygon it's already approached to the pi value, which is 3.141, which is we commonly use 22/7. 22/7 is equal to 3.142. so this is still here 3.141. the value of y we use 3.142. so let's move. So here 6144 sides. You can see if 6,144 sides polygon, how it will be circle. This is a 48 side circle, 48 side polygon, regular polygon, only 48 side, but here 6144 sides polygon. Here we are going to decrease the decimal. Okay, we can double it by 1 by 1. Here the number of sides is 384, and here 768, 1536 sides polygon. When we increasing the sides, you can see the last few decimals are changing. Up to this 5, there are no changes. This 8 becomes 9. From here this 0 becomes 2. Likewise, the very small changes are there. There are no huge change. So let's increase the size of the polygon more. Here 6000. Here the b value for b becomes 0 already. There are no space between this polygon and circle. It will already become 0. Let's go more. Here I told the 24,000 side regular polygon. So here 3.141 the value for pi. So that is how we can find the value for pi using Excel. So let's meet in another video with a new thing. Thank you very much.